Hey gentlemen, so our learning goal of section 1.4 is to learn how to use the distributive property to simplify expressions. Okay, so a couple things that we're going to need to learn in order to get there. First, we're going to have to learn the distributive property. It's probably a review for a lot of you guys. You've probably heard of it before. But then we're going to use that distributive property to work with expressions and understand what it looks like, what it means to simplify them. Okay, so to begin here, we're going to introduce the distributive property. All right, so we have any numbers. For these numbers, I'm going to use the variables a, b, and c because it works with all types of numbers. Okay, if that's the case, then if you have a times the quantity of b plus c, okay, then you can distribute that a to both the b and the c. All right, you usually will see it written out like that when someone's showing what they're doing when they're distributing, because you multiply a times b and then add that to a times c. It works also if you are subtracting, so a times the quantity of a times the quantity of b minus c is ab minus ac. You can distribute that a right in there just like that. Okay, so that's going to be really helpful when we're trying to understand what it means to combine like terms, and it's going to be really important for simplifying expressions when you have something multiplied by two numbers, a sum of or difference of two things in parentheses. Okay, we also need to learn what like terms are. So like terms are terms. Now remember that terms are things that are added and subtracted together. So like a, 17, 6a squared, 2a, all of those are terms. Okay, now like terms are terms that have the same variable or variables and the same power of each of those variables. Okay, so for example, we're going to pull out the like terms in all of these three quick examples. Okay, so a and negative 2a would be like terms because they have the same variable, a, and the same power of that variable. Since there's nothing, we assume it's the first power. Okay. Another set of like terms in that example are negative 6a squared and a squared, okay, because same variable, a, same number of each a, there's two of them, right, power of 2. And 17 doesn't have any other numbers in there, so there are no like terms with 17 in that example. Okay, and the second one, we look at these. Are there any like terms? No, they're not, okay, because although these first two both have x's, the powers aren't the same, so they're not like terms, so you can't combine these at all. Right, and lastly, if we're just picking out the like terms for number 3, we're looking for these here. We see the y's, okay, so 3 and negative 2y are like terms, okay, so they're like terms because they both use y and both a power of 1. Now these two, negative x squared and y squared, they have the same power. That's good, but they're different variables. X and y are different variables, so it would not work. So what you can do with like terms is you can actually simplify like terms. You can combine them together and add and subtract them. So this negative 6a squared plus a 1a squared, right? Since there's no number in front of the a, you assume it's a 1. So negative 6 plus 1 is going to be negative 5a squared. Right? And the positive 1a minus 2a, right? 1 minus 2 is negative 1, so that's going to be a minus a, and your plus 17 still stays on the end. Okay, you can't do anything with that second one. That third one, the y squared and the x squared, you can't do anything with because there are no like terms to combine them with. But the 3y minus the 2y is going to leave you with plus 1y, or just y. All right, and the last term, vocabulary word that we're going to learn in this one, is the word coefficient. So a coefficient is the numerical factor, so the number part of any term. All right, so we know that terms, we just talked about up above, are the things that are added and subtracted together. They could consist of variables, numbers, and powers. Okay, so the number part that's in front, not the power part, but the number part, is called a coefficient. Okay, so I'm just going to circle the coefficients here. All right, the first one at 6. Okay, that one's pretty easy. The second one's a little hard. It's not 3 because 3 is in the denominator. What this actually is, this x over 3 is actually 1/3 times x. Okay, so our coefficient is actually 1/3. So when you see a number in the denominator like this, okay, it's going to be 1 over that number. In the third one, okay, that y is just by itself, so we assume that the coefficient in front of it is 1. So the coefficient's 1. And the last one, right? The negative x, once again, we assume the coefficient, the number in front of it is 1 because there's nothing there, so the coefficient for that one is negative 1. Okay, let's hop into some examples. So, Julio walks 5 days a week. He walks at a fast rate for 7 minutes and cools down for 2 minutes. Use the distributive property to write and evaluate an expression that determines the total number of minutes Julio walks in a week. Okay, so total number in 1 week, we know he walks 5 times, right? 5 times a week. So 5 times both the fast part and the slow part. The fast part he walks for 7 minutes, and the slow part he walks for 2 minutes. Okay, so you got 5 times the quantity of 7 plus 2. Okay, because this is each day he was walking 7 plus 2 minutes, and he walks 5 times in 1 week, so the 5 is multiplied by how many minutes he walked for 1 day. So we can distribute this, and we'll have 5 times 7 plus 5 times 2. 5 times 7, remember, is 35. 5 times 2 is 10. Add them up, and we get 45 minutes. That's how long he walks in a week. Okay? Now, number 2, we're going to use the distributive property to rewrite this difficult multiplication problem, okay? 12 times 82. And then we're going to evaluate that. So you could use the distributive property to make this simpler in your head. Okay, because if I asked you to do 12 times 82, it would take you some time to set it up and work it out, or try to use a calculator. So you could turn this into something that you could do in your head by multiplying 10 plus 2 times 82, right? Because we can pretty quickly do 10 times 82 and 2 times 82, right? So if we distribute that 82 in there, notice how even though our 82 comes after the parentheses, you could still distribute it back in there. Right, we'll do 10 times 82. 10 times 82 is 820, right? We just add a 0 to the end. And 2 times 82 is going to be 164. Now we could just add those two up, which you could do pretty quickly in your head, and you'll get 984. All right, a couple more with the distributive property. We're going to rewrite each expression using the distributive property and simplify if we can. Okay, so we're going to distribute that 12 in there, and we'll have 12 times y plus 12 times 3. And the 12 times 3 we can actually work out. 12y you can't do anything with, so we'll have 12y plus 36. And in b, we distribute that 4 to all 3 places. Okay, so you can distribute it to more than just 2 things. Okay, so 4y squared plus 4 times 8y is 32y, and 4 times 2 is 8. Now, to simplify these like terms, right, what's actually happening here is you are doing the distributive property. Okay, so what's really happening here when you're adding a 17a plus 21a, you're really doing 17 plus 21a, right? You're thinking in your head, you are adding the coefficients and you're just putting an a at the end, right? So you're doing the distributive property. So 17 plus 21 is 38, and we still have our a there. In b, okay, we just combine like terms. Remember, this 6b is not a like term with these other ones because it doesn't have a power of 2. So we're just going to do 12 minus 8b, right? 12 minus 8, b squared, plus 6b. Okay, so the 12 minus 8 we could simplify to get 4b squared plus 6b. And that's the simplified version. Now the last problem here, we're going to have to write an algebraic expression for this verbal expression, which is 6 times the sum of x and y increased by 4 times the difference of 5x and y. All right, once we get it written out in A, we'll simplify it for B. Okay, so for A, we have 6 times the sum of x and y. So the sum of x and y is x plus y, and 6 times that puts 6 on the outside of our parentheses. Increase by means adding 4 times the difference of 5x and y. Remember, difference means subtraction, so 5x minus y. Okay, so that's our expression that's written out right there. And the second part of this, we're going to simplify the expression. So to simplify it, we need to distribute the 6 and the 4. Okay, so for the 6, we'll have 6y, or 6x plus 6y plus 4 times 5x is 20x. Oh, that's supposed to be an x. 20x minus 4y. Okay, now we can look to see if we can combine any like terms. Well, I see some like terms right here. The 6y and the negative 4y, and the 6x and the 20x. So we're going to combine those like terms, and we'll have 6x plus 20x is 26x, and 6y minus 4y is plus 2y. So our final answer is 26x plus 2y. And that gets us through section 1.4.